Hello students, today I am going to cover up lecture number 1 of unit number 5, that is your application layer. In this video, I will cover up domain name system. What is domain name system? What is the need of the domain name system? How it is categorized and what is DNS, distributed or dynamic DNS. So we will cover up these topics in this video. So firstly, I am describing the domain name system. The domain name system is an internet service that translates domain name into the IP address or vice versa. That means it divides the domain name into IP address and IP address to domain name. In general, when we want to search any page, we do not know the IP address. We simply puts the name. For example, www.gmail.com, www.amazon.com, or www.flipkart.com, and so on. So, but computer does not know these name address. It firstly convert the name given by you into the IP address, then after searches the pages. So, where this conversion reside? This is the one of the biggest question. So, this may be reside in your local computer, or there may be a DNS server in your organization, or maybe possible ISP have the DNS server, or maybe at the upper level. So firstly, the conversion is searched into the your local system. Now, where that file reside and what is the name of that file? That is the one of the question. So its name is the host.txt file, and it reside in Windows C, Windows System 32 drivers के अंदर, that is the etc, has the name file host.txt. Similarly, in the Linux, the file is /etc /host.txt. The host file was located in the hard disk and update periodically from the master host file. Master host file will reside maybe the upper level, that means maybe the DNS server of your organization, or at the ISP level, and so on. When any program or the user want to map the domain name to the IP address, an address that is IP address, the host consulted to the host file to found the mapping. Now, internet is not small, so it is impossible to have only one host file related to every namespace and vice versa. We cannot store the entire word domain name conversion on a single computer. So we are managing into the hierarchical level that we will discuss little bit later. So this is the example of the host.txt file. Here is the IP address name corresponding to that IP address is given. Suppose it's Microsoft.com has the IP address this one. Okay, YouTube have the IP address like this one. So it converts name address into the IP address. Now you can better understand by this diagram, as I have used www.google.com. So it will search for the DNS server. Firstly, it will search in my computer. If it will not find in my computer, it will go through to the DNS server. How the internal process is there between here, a internal process is there. We will discuss in the next slide. Here is the description. Firstly, it will search into the DNS client, means itself. If it found the conversion wonderful.com to the IP address, it will return back to the client itself. Otherwise, if it will not found, it will send to the upper level hierarchy for searching or conversion the name entered namespace into the IP address. So upper level, if it will not found in the upper level, then it will go to the next upper level. Here, this diagram can be more understandable by this diagram. Suppose its system searches for the an address www how howstuffworks.com. So it has not found the conversion into its host.txt file. It will search for the DNS server 1 at the upper level. If the DNS level upper just one level up to the this host will also not have the conversion. In that case, it will search to the next upper level, then next upper level, and so on. This process will continue. So there are total 128 levels may be there. In general, it may found the conversion within one or two or three levels, not more than this. But total there are 128 levels. So as it has found the IP address corresponding to that how howstuffworks.com, so it will return to the lower level DNS server. It will store in itself. Then after it will send back to the host and host will store itself. Then after the requested website will be visited. Next time, whenever it will again search the howstuffworks.com, it will consult to its local host.txt. It will not, it has not to go for the upper level DNS because the file will, the conversion will found in itself. So this is the process. The solution is used today is to divide the host name into a smaller part and store each part in the different computer. In this method, the host need a mapping can call the closest host holding the need of the information. Closest means itself or then after upper level, then after upper level. This method is used in domain name system. Now, how to give the name? The name is, assignment is a one of the biggest tasks. So there was two methods that were earlier deals. That was the flat name system. But flat name system suffers from number of problems. So number of problems are like this one. Each a flat name system, the name is assigned to an address. In name, in the space is a sequence of character without any structure. Suppose that I have written XYZ underscore ABC PXYZ. So there is no convention. If used I have used Arun Tripathi, this is a name, or I can use the Arun Kumar Tripathi. So yeah, AK Tripathi I can use. So there is no conversion, there is no dot. How can I come to know where is the separation? AK, A is the single word, K is the another single word, or Tripathi is another single word. I don't know. So that is the one of the biggest issue with the flat name space. The main disadvantage of the flat name, it cannot be used for a large system such a internet because it is centrally controlled and avoid the ambiguity or the duplication. So it is using Joe in sales, it is Joe's PC, it is gels and so on. It is using comma, it is using dot. So there is no predefined convention is there. So It is not used nowadays due to the numerous problems. Next one is the hierarchical namespace. In the hierarchical namespace, we separates each each by dot. For example, here this is dot, then after name, then after dot, then after name. Suppose that I want to use yahoo.com. Yahoo.com. Maybe possible this server is residing in US. If I want to concern with only the India server, I will write yahoo.co dot in. Yahoo.co.in. So there is a separate a specific format how to use the word. In hierarchical namespace, each name is made of the several parts. The first part can be define the nature of organization. For com means commercial or in means India. Second part defines the name of organization. Here I have used the type of the organization. Here the name of the organization Yahoo. Here I have used at the third level name of the organization and department and so on. So we can organize in a particular manner. So we will discuss in the next slides more here. For example, at the first level, I have used the working on divided on the basis of the working. For example, ARPANET related websites .arpa. Here, the commercial related.com, the education related.edu, organization related org, and so on. So this may be the organization or country, etc. Here I can again explaining by one example. Suppose that I am using edu. Sorry. Uh, Let me take the whiteboard. That will be better one. Without whiteboard, I will work better. It can be explained better. Firstly is the edu dot. Here is the dot. This one. Then after I have used the organization name as KIET at this level. Then after, if I am talking about the computer application department, then CA will be there. And then after, at the rate and name of the person XYZ at the rate CA dot KIET dot edu. So I have taken the 1, 2, and 3 level hierarchy edu, kite, and CA. So this may be possible. You can divide the department wise also. But if you want to leave it .edu, then after name of the organization, you can leave here. You can leave the CA XYZ at the rate kite.edu. It depends. So we will consider all in the next slides. Hierarchical namespace. At the top level, there is a root. Then after at the level 1 organization name or organization type. Then after domain name second part, and then after domain name third part, and so on. Each domain in the tree has a label. This is a domain. For example, .edu, .fhda.edu, and so on. So each have the label. The label has the maximum character 63. The root label is a empty string. There is nothing. The DNS requires that the children of a node have different label, which guarantee the uniqueness of domain. This will be unique. For example, this address will be unique. It will not be the copy of any other name, domain name in the world on the internet. Okay. There are three heads, total 128 levels, level 1, level 2, level 3. That means 0 to 127. The root will be at the 0th level. So this is the hierarchy. Now, this hierarchy can be seen by this one. Another way diagram, root server, then after edu server, then after .bk, suppose if it is a Berkeley, then it is using the naming convention .bk, and then after here is the department .csc, so csc will be there, and so on. So we can say at the top is the root, then after there is a domain. Domain may contain zone, and then zone may contains domain, and this recursive process may be there. So there are two types of domain name, fully quantified and partial quantified domain. If the label is terminated by a null string, if the label is divided by a ended with a null string, it is called fully quantified domain. If an FQDN is a domain name that contains the full name of the host. Here you can see www.funny.int dot. At the last there is a dot in each. So it will define the complete name. While if a label is not terminated by a null string, means not dot is not there. After dot there is nothing. Here after dot is something. It is called partially quantified domain name. Partial quantified domain name starts from a node but does not reach at the root. For example, here cs.hmme.com is not there. So this is the known as the partially quantified domain name. DNS on internet. So there are three types of the DNS on internet. First one is the generic domain, second one is the country domain, and third and last one is the inverse domain. So firstly, I am covering the generic domain. Generic domain is based on the type of the organization. For example, .aero aerospace, .biz related to the business, .com related to the commercial organization, .co OP Cooperative Business Organization .edu related to the educational institute .gov.mil and so on .net .org for non-profitable organization and so on. So we can divide the DNS on internet based on generic domain. For example, I am using .com .edu. Uh, our organization website is kind.edu. So I have divided, or we can say, we have purchased a domain name that are related to the edu, education related. So this is the complete address for the domain name, generic domain name. Next one is the countries wide domain name. So the country name come first. Then after the type of the organization will come first. Will come. For example, .in, .us, .uk, .au for Australia, and so on. So if I am using the address .in, means I am talking about the India. In India, I am using the education related server edu, and in education there is a organization KIET, and in KIET I am in the department computer application. So ca.kiet.edu.in. So this may be the type of organization that we can use. So this is the best example of the country-wise domain name. Next one is the inverse domain. Inverse domain. Basically, inverse domain is used to map an IP address to name and name to IP address. Sorry, it is map the address to a name. This may happen, for example, when a server has received a request from the client to do a task. Although the server has a file that contains a list of authorized clients, only the IP address of the client is listed. The server asks its resolver to send a query to DNS server to map the address to a name to determine if client is not authorized list. So this will be the process of the DNS inverse domain. So you should be noted that the inverse domain is used to map address to a name. Here is the example. Suppose that I want to search an IP address of a particular IP address corresponding to a particular address. So we can use as a NS lookup. NS lookup, I have used the gmail.com. So it will convert the name into the IP address if it exists. Suppose that I have given an unknown domain name abcdfghio.com. So cannot find the this domain name. So if the domain name exists, it will return back the IP address. Otherwise, it will not return back the IP address because the domain name is not exist. Now I will discuss DNS message format. DNS has two type of messages. First one is the query message and second one is the response message. The query message consists of two fields, header and question section, while response message consists of five section, header, question section, answer section, authoritative section, and additional section. So we will discuss each a little bit after. Firstly, we are discussing the header section. What are the field of the header section and what are the responsibilities of those fields? So here these are the six fields in the header section. The header is of 12 byte long. The fields are identification fields, flag field, number of question record, number of answer record, number of authoritative records, number of additional records. In the query message, these fields 1, 2, and 3, that means last three fields are padded with the 0 because they have no specific meaning. So now I am coming up with the identification field. Identification subfield is used by the client to match the response with the query. For example, the client had sent it the query number 1. When it will get the response from the server, so which is it is the response of which query? Or maybe we can explore more if the client had sent the three query 1, 2, and 3 and server sent back the response. So this is the response of which query number? Either 1, 2, or 3. So this number is duplicate by the server corresponding to response so that the client will come to know, yes, this is the response of the query number 1. Flex subfield. The flex subfield is a collection of the subfield that defines type of the message. It is the query message or response message, the type of the answer requested, and the desired resolution means iterative or recursive. In case of recursive, it will send the query to upper level, then it will send to the its upper level means level 2, then after it will send to the root or the upper level and so on. And then after, if the root server does not found the response in itself, it will send back to the that particular address requested, and the server and the client or the server that has the response, it will return back to the root server, and root server makes a copy, and then after it will return back to the client. So this is known as the recursive process. While in case of iterative, it will contact one by one to each server. First it will request to the this one, then corresponding to response, then after second one, then corresponding to response, and this process will continue. So now I am going to cover up rest of the fields of the response message and one field of the query message. So number of question record. The subfield contains of the number of queries in the question section of the message. How many queries are there? The number of answer record. This subfield contains the number of answer record in the answer section of the response message. It is set to be 0 in the query message. Sorry, we are talking at present these. So it is set to be 0. Now next, number of authoritative records. The subfield contains the number of authoritative records in the authoritative section of the response. This field is 0 in the query message. Similarly, the additional records fields is in the response query, while response message, while in the query message it contains the value 0. Now we are discussing the rest of the fields of the response and query messages. Till yet we have discussed only the header. Now the question section and answer section and authoritative section and additional section we will discuss. So question section. This section consisting of one or more question record present in both query and response messages. The question record. The question record is used by the client to get the information from the server. This contains the domain name. The answer section consists of one or more response record. It is present only on response message. This section includes the answer from the server to the client. Last one is the second last one is the resource record. Each domain name is associated with a record called the resource record. The server database consists of resource record. The resource record are also what is returned from the server to the client. So it will store that record what is returned, so that if the further some clients request the same record, so it will give the answer itself, not forward to the upper level. Authoritative section. This section consists of one or more records. It is present only in the response query. This section gives the information about the one or more authoritative server's query. And last one is the additional information section. This section consists of one or more resource record. It is present in the response message only. This section provides additional information that may help to resolver. For example, if a server is giving a domain name of an authoritative server to the resolver in the authoritative section and include the IP address of the same authoritative servers in additional information the section. So these are the basic message format. Now I am coming up the dynamic domain name system. The dynamic domain name system is used nowadays because the IP address may change, or this is not possible to manually update each time as in the DNS. When the DNS was designed, only no one predict there will be so many address change. In DNS, whenever there is a change, such as addition of new host, removing of host, changing of IP address, change made by the DNS master file, and so on. So these update has to manually done by the administrator. The so if this to make it automatic, we requires the dynamic DNS. For example, if the IP address is changing to a DNS server, to a domain name. For example, when the system is gets up, it will request to the IP address. A IP address is assigned. Now, whenever a new IP address is assigned to a particular domain name, it will send back to the DNS update to the dynamic DNS server. So, update dynamic update will be there as the address changes. In DNS, when there is a change, such as new adding of new host, removing of new a host, changing of the IP address, the change in the DNS in the master file. These types changes involves lots of manual updating. The size of the today's internet does not allow for this kind of manual operation. The DNS master file must be updated dynamically. The dynamic domain name system therefore was used to respond the need. In DNS, when a binding between name and address is determined, the information is sent to the primary DNS server. The primary server updates the zone. The secondary server notified either actively or passively. In active notification, the primary server sends the message to the secondary server about the change of the zone whenever, whereas the passive notification, the secondary server periodically checks for any change. In either case, after being notified the change, the secondary requests the information about the entire zone. It is known as the zone transfer. So question may be asked, what do you mean by zone transfer? Means secondary server requests the information about the entire zone, so entire zone will be transferred. The provide To provide the security and preventive unauthorized changes in the DNS record, DDNS can be used as identification mechanism. So this was all about the DNS. If you have any query, you can ask me on my mail ID. This is my mail ID. Thank you.